My name's Ian Massingham. I'm a Chief Evangelist with Amazon Web Services for Europe, Middle East and Africa region. I'm actually based very local to Manchester, so it's great to be here today without too much travel time, let's say. Okay, normally I'm a little bit further away from home. What I want to talk to you about today is adoption of the cloud and adoption of AWS, and what some of the patterns are that we observe in the way in which customers make use of cloud computing today. Before I do that, it's really helpful for me just to understand what kind of knowledge there is of AWS in the room. So let me just ask you a quick question. Who here is using AWS today to run production applications or workloads? Anybody in the room? A minority of people, okay. And who has experimented with AWS in some capacity? Okay, a little bit of a larger contingency. Okay, so most of the content today is going to be introductory in nature then, okay, because the majority of people here I would describe as new to Amazon Web Services and probably not doing that much in the AWS cloud today. Okay, and I'll try and balance the content so it's more appropriate for that kind of audience. So what do we think? Well, first of all, you guys, you're quite early in your adoption journey, the majority of you, but actually what we've seen is for most larger organizations today and organizations that intend to scale quickly, actually, it's more of a discussion about why they shouldn't use the cloud than a discussion about why they should use the cloud. I'm talking here about new application build and new application deployment. And there's also a strong benefits case for migrating existing applications to the cloud, to AWS, for a few reasons that I'm going to talk about in a lot more detail later in this session. I'm going to illustrate those reasons that it's a good idea to make more use of the cloud with a few examples of AWS innovation. So a few examples of new things that we're doing to make the cloud a better target for applications of all types and to help customers, particularly customers that are established in nature, that have been around for a few years and whose IT is really characterized by existing applications, in a lot of cases legacy, to make those kinds of organizations much more enthusiastic about making use of AWS, okay? And I just want to illustrate that this hypothesis that it is the new normal way to do IT with a few case studies of customers that are using AWS today. This is a set of logos of startup organizations that have built and scaled new businesses that are technology dependent on the AWS cloud since we launched back in 2006. And I'm sure you'll recognize a lot of the logos on this slide, organizations like Airbnb or Tinder or Flipboard or Shazam or Twilio or Slack or Sumo Logic or Dropcam. They're all building brand new applications on AWS, and they're doing that because the cloud offers a really compelling set of benefits for innovators, for people that want to create applications with a very low starting cost base, and they want the ability to iterate on their applications very, very quickly in order to make sure that what they deliver is as close as possible to the needs of their customers. Okay, and this is a real trend that we see in startups. If you go to a VC today, to a venture capital fund, and try to raise money to start a new business, and you tell that VC that you're going to spend, I wouldn't say a significant proportion, any of that capital that they're going to give you on fixed assets like data centers, computer hardware, and software, the VC will just tell you they're not going to invest in you. Okay? VCs do not give money to startups to buy hardware and infrastructure. They give money to startups so that the startups can create a sustainable business model and give the VCs a return on their capital, okay? And if you're investing their capital into infrastructure, then you're not using that capital on it for its intended purpose, which is identifying that sustainable business model and creating a startup business which has long-term viability, okay? So you just can't get money to create a startup if you're going to spend that on infrastructure. And it's de facto today that if you're going to build a high-growth technology business, you build it on the cloud, and you don't build it on the cloud using infrastructure components, you build it on the cloud using services, okay, and we'll talk a lot more about that later in this session. That was, say, the picture of AWS usage up to, say, 2012, 2013. Most of the usage was in startups, but what you've seen since then, so over the last 4 years, is a real shift to mainstream adoption of AWS amongst more established enterprises that have been around a long time. And I've illustrated this actually, the top row of this slide, sorry, is comprised of organizations that are predominantly headquartered and operating here in the UK. So did you know, for example, that the Financial Times digital product portfolio and all the subscriber analytics and other services that go with that digital product portfolio is delivered exclusively on AWS. Did you know that ITV player application for delivering their digital content to tablets, mobile phones and PCs is built substantially on AWS? Did you know that EE make use of AWS for their customer care and account management applications? If you top up your EE phone, you're using Amazon Web Services to do that. Did you know that Ocado have over 250 different applications running on AWS to support their retail operation? Did you know that News Corporation deliver the digital versions of the Times and the Sun newspaper 100% on AWS infrastructure? Or did you know that every time you look at national rail inquiries to establish how long it's going to take you to get into Manchester, or like I did yesterday to get from Leeds to Manchester to do this event, that query is being handled by a set of APIs that run exclusively on Amazon Web Services. So we've got very broad adoption amongst enterprises here in the UK. And if you look down this slide, you can see logos from Fortune 1000 organizations in pretty much every conceivable vertical market and every conceivable geography around the world. So it is perfectly normal now for enterprises not only to adopt AWS, but to adopt something that we call a cloud-first strategy, which means they're building all of their future applications on the AWS cloud, and they're also migrating what they have to us at a pretty rapid clip as well. And at the end of this session, I'll return to that and talk a little bit more about enterprise use cases and how some of these customers make use of AWS today. Okay? So there's really substantial adoption. The analyst perspective on AWS is very interesting. This is us up here in this top right-hand corner. This is a Gartner Magic Quadrant. I'm guessing a lot of you will be familiar with these. You've probably looked at quite a lot of these during your career, and I've certainly looked at a lot of them. Do you know how unusual it is to get quite so close to one of these axes? Okay, if you look at another one of these quadrants, it's very unusual to see any vendor, any provider, get quite so close to the extreme axes on the chart. Okay? And there's a reason for that really with AWS, which is and we're talking here about completeness of vision, which is about the rate of evolution of AWS services and how quickly we're adding new features to the platform that customers tell us and therefore tell Gartner that are important to them. So for example, in 2015, we delivered 722 new features and service enhancements, which is an average of around about 2 a day for every single day of the year. Okay? And when we do enhancements, when we do innovation with the platform, we have what I always call a customer-directed model. So 90 to 95% of the things that we choose to build, the ways in which we choose to enhance the platform, comes directly from customers saying to us, AWS, it'd be really helpful if you could, for example, make it easier for me to manage cryptographic keys in the cloud. And we hear this from a few different customers telling us the same thing. And we build features on that basis. Okay? And we're constantly reprioritizing our roadmap, the thing that we're going to do next, the things that we're going to do next, in accordance with what customers tell us their current priority set is. And that's the process that we use to get quite so far over on that completeness of vision axis, because it's not our vision, it's the vision of all of the million customers that are using AWS in any 30-day period, synthesized and turned into our roadmap, which we then work upon. And you'll find that is, in my experience, quite different to the way in which most technology providers work. Most technology providers, unfortunately, particularly in legacy technology, they don't really talk to the broader base of customers. They have a few customers that they talk to, or they come up with ideas internally, and they release products, and then they look at them and think, well, why wasn't that adopted? You know, why didn't customers use that? And the answer is simple. Customers didn't actually want what they've built. Okay, so you've got to regularly check that you're doing the right thing and that you're closely aligned to the current needs of what your customers are, and that's something that we focus on really hard. The other thing that's interesting about this report that goes with this Magic Quadrant is the narrative, and what Gartner said in their narrative for 2015, which came out in May last year, so it's just due to be refreshed, was AWS have roughly 10 times the amount of deployed capacity than everybody else on that chart added together. Okay, so we're 10 times the size of the next 14 competitors, and that's allowed us to build out this. So this is our global footprint. An AWS region is a geographical location in the world where you can access AWS services. We concentrate them into particular locations because a region is not a data center. A region is a data center cluster. We organize the cluster into something called availability zones. So for example, over in Dublin, Ireland, we'd have 3 of these availability zones. We call them AZs because we're American, or the people that run the company are American. And those AZs allow customers to distribute their application across different failure domains. So if you put parts of your application in availability zone 1, 2, and 3, we do everything that we can to ensure that failures that impact zone 1 will not impact zone 2 or zone 3. So it's separate power, separate networks, separate floodplains. Some parts of the world we distribute them to avoid fault lines, like in California we have a region where we put the availability zones in areas where they won't be impacted by the same earth tremor, for example. And this means that we have a very strong platform upon which customers can build applications with very good availability characteristics, very good durability. Okay, so we actually have 33 of these AZs around the world. Each availability zone has between 1 and 6 data centers in it, so we have between 33 and 189 data centers around the world. And we're opening 5 more of these regions in the coming year. Ohio, Montreal, importantly here in the UK, close to London, another one in India, and a second region in China. Okay, so we're going to go from 12 to 17 regions by the first quarter of 2017. Okay, and they can be important for compliance, they can be important for performance, they can be important for data sovereignty, and they can also be important for cost. It's slightly more cost efficient, for example, to build your AWS resources in Dublin than it is to do in Frankfurt because of differential in operating costs, and we just try and pass the minimum amount of costs on to customers, obviously. So that's a bit about us, and that's all about, you know, who we are, who uses us, what our platform is. I want to talk now about why customers choose to use AWS. And there's 6 kind of quite analytical reasons that customers will use us, okay? And then I'm going to talk about some more emotional stuff, triggers that make technical end users and developers want to build in the cloud. But this is kind of hard, evidential-based stuff about why you might use the cloud in preference to more traditional delivery models where you've got to buy and operate your own infrastructure, for example. So the first thing is, it's not a capital model. You pay as you go for the resources that you consume. If you're consuming a lot, you pay more. If you're consuming very little, you pay very little. And that means that any kind of workload which is cyclical in nature or which is variable in nature is normally going to be very cost advantaged to run in AWS versus running it yourself. We also have a mechanism for reserving infrastructure. So if you do have a workload or a service that you're going to run for a long period of time, say 12 months or 3 years, you can pre-commit to the capacity that it needs, and in return for that pre-commitment, we'll take between 50 and 75% off your bill. Okay? So if you're doing cost comparison for a long-term workload like a relational database, an ERP system, something else that's going to be around for a while, always look at these optimization, cost optimization options that are available to you and make sure that you're using our services in the most cost-efficient way. We don't want you to pay us more than you have to. We want you to use your scarce financial resources on things that are more valuable to your business and give us the minimum amount of money. Okay? And we give you optimization tools that you can use for that. We also have a team that can help you model your workloads or applications and understand what the most cost-optimal way to run them in the cloud is. So you should talk to us if you're in that situation. We can help you. Okay? And there are some other benefits as well. I'm not going to cover the rest of these in a lot of detail because some of them are quite developer-centric. And I'm going to return to the second topic now, which is why are developers so passionate about using the cloud? Did you know we've got an AWS user group up here in Manchester, which is organized by the community, and I can see at least one person from the user group in here right now, so I'll talk about you a bit, Anne. We've got about 550, 600 members in that user group. This is a self-organizing community of users that are giving up their own time to learn and educate others about AWS. We've got another one in London with almost 3,000 members. What is it that motivates developers to engage in these communities, and why is it that developers are so enthusiastic about building on the AWS cloud in comparison to the delivery models that they might have grown up with or learned about in university or had suggested to them by other technology providers? And I'm going to cover 3 reasons for this, okay? The first thing is there's a strong push factor, okay? So traditional IT, if you're a developer, it's not a whole lot of fun to work with traditional IT, okay? It's, the main word I would use to characterize it is slow, okay? It takes a long time to get anything. I want to spin up a development environment. I want to experiment with a new product. I want to try something out. I'm in a 3-6 month cycle of trying to buy the infrastructure that I need to do that. And even if I've got a virtualized platform that I've pre-invested in, it's very inefficient because it's fixed. You know, you can't take it away. You always have it on your balance sheet. It's always depreciating, and it's always in your financial model. Right? With the cloud, you can flex that. Okay, so you can use as much capacity as you need when you need it. The other benefit, of course, is flexibility to use and access new services. So what it gives to developers and to innovators is a lot more freedom, okay? The ability to access the services that they need when they need them, to experiment, to scale, to fail, and to take capacity out and services out if they don't need them, and to do that in a way which just makes it a whole lot easier to get stuff done, okay? That's definitely how I feel about working with AWS, and when I talk to developers in these user communities, they say the same thing. So just focusing on this in a little bit more detail, the first thing is this ability to build without restriction. And one of the ways we do that is by making it very quick and easy to provision resources. Those might be infrastructure resources, or they might be higher level abstracted services that deliver other outcomes for customers. The whole thing is abstracted behind an API. And with that API, we provide a console, which is a graphical interface for creating, modifying, and deleting resources. We also provide a set of software development kits, so developers can programmatically control or access AWS resources from within their own software. And we also have a really strong community contributed ecosystem of commercial and open source tools that use those same APIs to add additional automation and additional control capabilities. Okay, so there's an ecosystem around the AWS API that allows you to get speed and agility out of this technology platform. But of course, the platform itself is also pretty important. We have over 70 different services today, and many people that come, who comes to this session as somebody that works in IT operations and has worked in IT operations for a period of, say, more than 5 years? A few people? Yeah, quite a few people. Like I used to do, okay, you probably think about your IT resources in terms of servers, virtual machines, storage arrays, network switches, and the whole thing sits in a data center, right? I mean, that's the sort of mindset that you probably have, and I was as guilty as that myself even 4 years ago, before I really started learning in earnest a lot more about AWS. And we do have those services. They're all down here, okay? So infrastructure, it's our regions and our AZs, and core services are compute, storage, content distribution networks, relational and non-relational databases, and then a set of networking services, okay? And you can still use AWS in that way. You can still take those building blocks and you can build your own infrastructure on those building blocks in the same way that you would with traditional approaches, okay? You still get the same benefits of our multi-AZ, multi-region infrastructure. You get compute resources and storage resources that you can provision in minutes, pay for by the hour, reserve if you want to reduce your costs over time, and then discard when you don't need them. Okay, so you can still use it that way, and you'd enter the stack here at this level if you were doing that. But what we've done since 2006, when we started with those foundational services, is build a lot of abstraction layers on top of those underlying resources. Okay, so if you want to provision, say, a data warehouse, okay, one way you could do that would be to obviously work with business unit users, maybe as a solutions architect, to figure out what the business wanted to do with its data. A common scenario might be acquisitions. Okay, I've got a company, I've acquired another one, we've got two large data sets now, we want to merge those together so we can get some insights out of that combined larger data set. It happens a lot, okay? Now, you've got to buy a data warehouse to do that so you can integrate those data sets, or you might have a data warehouse that you need to scale. So you're looking at vendor relationships, you're looking at infrastructure technology, you're looking at installing software. Well, you're looking at procuring software and infrastructure, then you're looking at installing it, commissioning it, testing it, and finally you can start to integrate your data and start to do what you wanted it to do in the first place, which is find out more about your customers maybe from this enlarged data set. How long does that process take to do that inside your company? You said a second ago you had an infrastructure-centric role, so building a new data warehouse from scratch, how long? 6 months. That's actually pretty consistent with what I hear from most customers. We've got a service up here called Amazon Redshift. Call our API or visit our console. Dimension the data warehouse that you want in terms of size. Say whether you want solid state or rotational disks. We'll marshal these lower level resources and we'll create that data warehouse for you. In about 10 minutes, you'll have an ODBC or JDBC endpoint that you can start loading your data into. In the AWS Marketplace, which is an environment for accessing third-party software tools on AWS, we have a whole collection of different business intelligence vendors from the likes of Tableau, through Qlik, through Pentaho, Jaspersoft, all sorts of different ones. You can pick 5 or 6 of those, provision them all with a one-click experience through our marketplace, connect them all to your data warehouse, and choose which visualization tool best suits your purpose. If you don't like any of them, you can discard them and use something else. So we've got a standards-based interface. And if you don't like Redshift for some reason, or if it doesn't quite fit your use case, you can discard that as well, and you can go back to plan what you consider to be plan A, which was the traditional procurement model, and start on your longer journey of selecting vendors. The whole process that I've described to you with Redshift and those other tools might take 2 days and cost $100. So why wouldn't you do that? And when I talk about abstraction layers and about higher level services that make it easier to get stuff done, that's one very good example of one of the 70 or so different services that we have that can help you do that. So just think differently about the way in which you acquire IT resources and the way in which you provision them, and get away from this traditional mindset of always thinking about everything in terms of infrastructure building blocks, okay? It's not a good way to do it. I used to do that myself. How wrong I was to think about infrastructure that way, okay? It's all about services and outcomes. It's actually not at all about infrastructure. Okay, infrastructure is just a necessary evil that you have to invest in and provision in order to get to the outcomes that you want, right? Agree? Yeah, most people are nodding. Good, you're on the same page. So that's that Redshift's relatively traditional service that replaces data warehousing. What about stuff that's a little bit more innovative? Okay, so some time ago we announced a brand new service called AWS Lambda, and this has led to the rise of a new term, which is kind of interesting, serverless architectures. Anyone heard that? A few people, okay? Now, you know the secret, there are actually servers, okay? They're just called serverless architectures. There are actually servers. There are actually CPUs, memory, I/O bandwidth, and everything else that you have in a server, okay? Because the code has to run somewhere. Maybe what it should be is managementless architectures, because you never have a server to provision, to maintain, manage, scale, repair, replace, upgrade, okay? All you have is software, okay? You have code. You upload that code to AWS, which takes a few seconds, okay? And then you connect that code to trigger events, okay? So something's going to happen, and that's going to result in that little bit of code that I uploaded getting run. That something could be hitting an API endpoint, like a web services API endpoint. That's a very common use case. It could be data processing. You deposit a chunk of data in one of our other services. When we get the data, we trigger the code, and we give the code metadata about the data that you just uploaded. The code then ETLs or processes or transforms the data, and after it's done that, it expires off the system. So you have nothing to provision or manage. We bill for it in increments of 100 milliseconds, times 128 megabits of memory footprint, so it's sub-second billing for the amount of capacity that you use. And it's broadly adopted. All of these different organizations are making use of AWS Lambda today in production. Okay, there's a lot of different stuff here. I'm actually going to talk about another example that's not on the slide. UEFA, they did a campaign associated with Euro 2016 together with David Guetta called This One's For You. In fact, he just released the single that was created as a result of this campaign, and they enabled it through browser-based audio recording. Okay, so you can go onto their web application in your browser, and you can sing and have your voice captured, and then David Guetta used this audio to composite together this track. He actually got 1 million voices recorded using this app and a physical recording studio that UEFA ran around France on a train for several weeks, with the same application running in the physical recording studio, encouraging people to come along and sing. Okay? The people that built it are a digital agency based in Leeds called Parallax. They calculated that it would cost them $12,000 a month to build this application using a traditional N-tier architecture. So front-end, mid-tier, database, load balancers. And the reason for that is really availability and scaling considerations. Okay? So they were given some predictions about how much traffic they would get, and they were given some predictions about what availability, or targets about what availability level they should build for. So they had to design something which was distributed and at quite high scale in order to deal with the spiky nature of the workload. At some times of the day, they thought they would have a lot of traffic. So $12,000 a month, and that's using AWS, which is already significantly more cost-effective than building the same thing with servers. The campaign was to run for 3 months. So if you were going to buy infrastructure for that, you'd have to either write down that capital investment over that 3-month period, or guarantee that you had something else that you could use that infrastructure for at the end. Both of those things are pretty hard to do, right? So they built it on AWS Lambda. They had their $12,000 cost, and for the first month of operation on Lambda and with other AWS services, it cost them $9.30. So it's 1,000 times cheaper. Then they got really busy, okay, in month 2 and 3, and it cost them $179 in month 3. But most of that was the accumulation of the million recordings and the million social media images that they generated for customers that had recorded the tracks. So most of the cost was actually in storage, not in compute. Okay, so I just want to illustrate to you just how using some of these innovative new services breaks the connection between outcomes and cost. Okay, it's just a different way of developing software, which is way, way, way more efficient. So AWS Innovation, the fact that we're pushing hard with this 722 releases last year, and very innovative service features like AWS Lambda, means that you shouldn't really look at cloud providers as commodities. If you're going to look at only basic services, you can compare across several different ones. But if you do that, you're leaving so much opportunity on the table for greater efficiency, responsiveness, agility, and reduced cost that it's, I mean, it's better than running your infrastructure on premise because there's no capital investment, but it's still not as good as using the cloud if you take advantage of these advanced service features that can give these abstractions, make you much more responsive, and make you much more cost agile. Okay. So the second thing is getting data in and out of the cloud. Obviously, to work on data with resources in AWS, you need to have your data close to our computing power, close to the services that we provide. We have several different options for this, okay? It's traditionally been things like direct upload, so our APIs are publicly accessible. You need cryptographic credentials to access them, but you can send data to our public endpoints over the internet, encrypted using SSL TLS. And by doing that, anybody can push data into the cloud. Any authorized user, rather, can push data into the cloud. We always have something called Direct Connect, which is a private high bandwidth network connection that you establish straight from your data center or network directly into an AWS region. And a good example of a customer using this in the UK would be BBC iPlayer. So BBC have two 10 gigabit direct connect services that go out of 2 BBC digital playout locations. Whenever they broadcast a program, they stream a high quality digital version of that to AWS in our region in Ireland. They use our compute resources to transcode the video, and that's how they make all of the different formats that are required for iPlayer to be successful available to viewers. Okay, and they use Direct Connect because it's off the internet and they're unwatermarked digital assets at 4K are extremely valuable items that probably pirates would like to get their hands on quite a lot. And secondly, it's performance consistent, so they know that they can hit their target of having their content available on iPlayer as soon as possible after broadcast on the linear playout service. Okay, so that's a great example of a customer using Direct Connect. Another trend we've seen is increased desire for customers to store and process real-time streaming data in the cloud. And for this, we have a specific set of services that enable it called Amazon Kinesis. And this is for small, frequent data packets, events, or messages that you want to send to AWS. We have something called streams, Kinesis streams. Will sequence your data, enable you to consume it with a variety of different consumers. Firehose, which allows you to take this streaming data coming with high frequency and reliably load that into other AWS services like Amazon Redshift that I mentioned earlier, so you can query your data as it accumulates over time. And also, we're bringing something out later this year called Kinesis Analytics, which allows you to operate on streaming data with SQL. So that's also going to be helpful for customers that want to pre-process data as it flows into the cloud, maybe only storing or forwarding records that meet certain characteristics and doing that evaluation in real time on each piece of data. It's very important for use cases like real-time analytics, industrial control, gaming, broadcast, ad tech. They're all applications that generate large volumes of time series data, and this service can help customers manage that in a simpler way without having to, for example, deploy, scale, operate, and deal with failures in something like Apache Kafka, which is another stream management infrastructure. So we're trying to fill out the developer tools to make it easier for customers to build high-scale applications in the cloud. We also have another pattern, which is connected devices. So anybody here got an interest in IoT? I definitely have. I'll happily put my hand up. So connected device applications, they're becoming increasingly common. We announced this service at AWS Reinvent last year, which really allows you to avoid some of the heavy lifting associated with connecting small devices to the cloud. We actually had a lot of customers using AWS for this application before we launched the service. And at reInvent, we had John Deere. Did you know John Deere have got 200,000 self-driving vehicles deployed? And they're literally in the field. So it's agricultural equipment, things like planters, harvesters, plowing equipment. It's driven by computers. Telemetry data is streamed to these devices from the cloud. There's an operator in the cab, but they're only there to hit stop in case of a safety emergency. They don't actually drive the vehicles. And the reason for that is they use data to do things like control the planting process. They'll have a detailed map of every field in a farmer's holding, and they'll, for example, plant the wheat at different depths or inject different fertilizer with the planting process in view of the different soil conditions that might exist in the same field. And it's all about optimizing yields. And all that telemetry and control is done using AWS services. Now, there are some difficulties in building connected device applications, things that developers have traditionally had to focus on, things like poor quality networking, particularly in rural areas. I mean, I just talked about farming there. Got another customer in the Nordics called Telenor Connection, literally connecting sheep to the internet with wearables. And another one in Scotland called Ice Robotics that does the same with cows. Okay, so it's big in agriculture. Network is not great in rural areas, so that's something you've got to overcome. High volume of devices, and of course, one of those farm machinery items is a safety critical system. You know, they've got a motor in them, they weigh hundreds, tens of tons, and they're moving. So you can't have somebody unauthorized controlling them, right? So security is also a critical requirement for these kind of apps. And we launched a service, as I said, at reInvent last year called AWS IoT. And this really allows developers to securely connect and manage devices at any scale. And we have this available in 2 regions here in Europe. And it offers features like these, really. So a device gateway, a rules engine for routing data that comes off these connected devices, a shadow, which allows you to work with a device while it's not actually online, so an asynchronous representation of the device in the cloud that allows you to read and write information from or to a sheep or a cow while it's in a river valley where it's not accessible via radio. So you can still get state off that, which allows for the creation of very battery efficient devices that can periodically synchronize data and then switch themselves off, and then switch themselves back on again and synchronize data 3 hours later. So that's a very important feature. Security, as I talked about, and the data connection. So we started touching a little bit there on security, and this is a super, super interesting area for me for a couple of reasons, actually. First of all, if you asked a poll of 100 CIOs 4 years ago what the main reasons they wouldn't adopt the cloud were, what do you think the top 1 or 2 were every time? It's security and compliance. Okay, I have to secure my data, and I have compliance standards that I have to meet. If you ask the same 100 CIOs today why they would adopt the cloud, what do you think the top 2 answers for adoption are? Security and compliance. Okay? Because we've done, AWS particularly, done a lot of work in achieving compliance accreditations and working proactively with customers to help them satisfy their security needs. So if anybody tells you that the cloud is not secure or that you can't achieve compliance in the cloud, that person is not well educated, okay? You should send them to talk to me. I'll explain them a little bit more about how and why you can do this stuff. So the first thing is the platform components that we provide, whether it's EC2 or Redshift or Amazon S3 or our IoT service, we work really hard to get those services certified so they comply with information security standards. So you want to run a PCI DSS compliant workload on AWS to store and process credit card details. That's fine. A subset of our services are pre-accredited for PCI DSS. When your auditor comes along to verify the application that you've written, you can just give them our controls report. We have that independently audited by, I think it's Ernst & Young in that case. And they can then look at that, and you can then audit your section of the application that you've built on top of our pre-audited platform. Okay? We have around about 1,800 different security controls that we apply. And when new and relevant standards come along, in most cases, it's simply a matter of us mapping our controls, our pre-existing controls, onto the new standard, like we did with this one, ISO 27018, which is a standard for privacy in the cloud. We map our existing controls into that. We're able to get certification for new information security standards very quickly. So you shouldn't fear accreditation of your standard, your applications to meet these security standards if you want to run apps in the cloud. It's very easy to do, and thousands, if not tens or hundreds of thousands of customers have already done it. Okay? So that's about compliance. About technical security features, we continue to build out features that customers tell us are important to them in enabling to use enabling them to use AWS for security critical workloads. I mentioned an example before about customers asking us to build better systems to enable them to manage cryptographic keys in the cloud. And we've created a service some time ago called the Key Management Service that you can see here, which allows you to create, store, and manage cryptographic keys in AWS with complete auditing capability and complete repudiation capability, so the ability for you to lock or delete keys at will. And you can use those keys as a trust root for application secrets, database encryption, record encryption within databases, or even for, and this is the most common use case actually, simply encrypting data at rest, so that when your data is stored in AWS, it's automatically encrypted, and if anybody gets hold of the media that it's stored on, all they'll see is white noise on the media. Okay? And we've got many other security services in identity, in networking, and in compliance and auditing as well, which are also relevant. And what we're trying to do here with information security in the cloud, in AWS, is basically remove this trade-off. There's been a long-term trade-off in InfoSec. You either move quickly or you had security. Okay? And when you came to try and ensure that things were secure, that meant auditing, and it quite often meant retroactive work to fix or change the way in which applications are built. That's not our model. Okay? Our model is this. Use the technical features that we provide to define guide rails. Okay, so I want my resources to follow this policy. And every time a developer in your account creates a resource, you can validate that the resource that they've created complies with those guide rails that you've specified. And if it's outside them, you can automatically remediate that and fix it, or you can send an alert to your InfoSec team saying a developer has created something outside of policy. Go and take a look at it. And that means that customers can really start to break down that trade-off. They can move very, very quickly with innovation, deploying new software releases very fast, launching new products very quickly, staying very closely aligned to the needs of their customers, whilst at the same time making sure that they meet information security and compliance requirements that might lay upon them. Okay, so again, think differently about InfoSec in the cloud. The cloud is secure, and in fact, many customers are coming to the realization that you can be way more secure in AWS than you can be in owned and operated infrastructure. You have a lot less to do. Everything's abstracted and controlled behind those APIs, so nobody can get to your infrastructure unless you give them credentials to allow them to do so, and you can audit that. This is why the CIO of Capital One, a guy called Rob Alexander, is CIO in the US, and Capital One in the United States are a full-service retail bank like Barclays or NatWest are over here. He got up on stage at AWS Reinvent in October last year in front of nearly 20,000 AWS customers, and he said, quoting verbatim, "Come to realize over time we can be more secure in the public cloud than we can be in our own data centers." And that's the head of a Fortune 250 global financial services organization saying that. Then went on to talk about how Capital One had moved their retail banking mobile application onto AWS in North America as the target platform. And now all Capital One customers in the US bank using their mobiles via a set of AWS service components which Capital One control and govern on their behalf. Okay, so you can be very secure in the cloud. So I'm just going to wrap up and say that the last freedom is the ability to say yes. And I've touched upon this quite a few times already. So much easier to get things done, access to resources on demand, a very broad range of different service components, and this flexible model that allows you to optimize. As I said at the top of the session, this has really led to significant continued adoption of AWS among startups. Okay, so if you're launching a business today and it relies upon technology, come and talk to us. Okay, we work with accelerator and incubator programs. Startups that are in those programs can get access to tens or even hundreds of thousands of AWS credits, dollars of AWS credits to help them build. We have a program called AWS Activate for that. So if you're thinking about starting a technology-enabled business, come and talk to us. And if you're in an enterprise and you're not using the cloud yet, look at some of these examples of customers that have done great stuff with digital transformation in the cloud. So you don't have to try and bite off and chew the whole of your IT infrastructure. It's not possible to do that. You can start with new product and service launches that are intended to improve the experience for your customers, maybe make you a little bit more competitive against some of these new startups that might be disrupting your market. And you can do that in a way which is low risk and very low cost, and can also meet the security and compliance requirements that you have. Even if you're operating in healthcare, in e-commerce, or in personal finance, it's very possible and it's very easy for you to build applications in those segments and run them on the AWS platform.